Hello everyone. In the last video, we discussed about the coordination number and packing of a crystal lattice in one dimension and in two dimension. In this lecture, I am going to start with the continuation of the last topic, packing of a crystal in three dimension. But before, if you are new to my channel, then please subscribe the channel, share the videos and like the videos as well as press the bell icon. Now here we discuss the close packing in three dimensions. The real structures of a crystalline solid are three-dimensional structure. These are obtained by stacking one above the other two-dimensional AAAA type square close packed crystalline structure, or by stacking two-dimensional ABAB type hexagonal close packed structure. Then first we discuss about the three-dimensional close packing from two-dimensional AAA type of square close packed layer. In this arrangement, the two-dimensional AAA type square close packed layers are placed one above the other. These are placed in such a way that the crest of the all sphere are in contact with successive layer in all direction. Here these are the crest of the sphere, this rounded part, and these are aligned in all four layers, 1 2 3 and 4 layers. All spheres of a different layers perfectly aligned horizontally and vertically. Horizontally like this and vertically like this. Forming unit cell having primitive or simple cubic unit cell like this. This upper four sphere forms this upper four corner of the cube, and this lower four sphere forms these corners. In this way, this is a cube. So it is called as it is a simple cubic structure. Since all the layers are identical and if each layer is labeled as A, then whole three-dimensional crystal will be AAA type. Each sphere is in contact with a sixth surrounded sphere. Like this. This is our particular sphere and it is in contact with this sixth sphere, that is the 1 2 3 4 5 6. Since each sphere is in contact with the sixth surrounded sphere for being the same plane, out of these six, these four lying in a same plane, one is above the plane and one is below the plane. Hence, the coordination number of each sphere is 6 due to SCC structure. In this type of structure, there is a more empty space in the crystalline structure. Then next one is the three-dimensional close packing from two-dimensional ABAB type hexagonal close packed layers. Then first we discuss about the formation of a base layer or the first layer and later on second layer. In ABAB type planar two-dimensional structure, consecutive layers are different. This is layer A and we place the second layer in the depression of this first layer here. So this is actually two-dimensional structure ABAB. Since the crest of sphere of a one linear layer are in the depression or the crux of the other linear layer, it results in the formation of hexagonal close packed structure with a minimum empty space. To obtain a three-dimensional crystalline structure, more layers are to be built on the first or the base layer. This is our base layer or the first layer, and for three-dimensional arrangement we placed more layers above it one by one. The base layer, even if it is of the type ABAB, now for convenience it is called as layer A. Suppose this is our layer A, which is the base layer or the first layer of this three-dimensional close packing. Then we discuss about the formation of second layer. This is our first layer or the base layer. Later on we discuss about the formation of a second layer. In the first layer or the base layer, there are two types of voids or the depressions are marked. Two types of voids. These are the triangular voids or the space which are pointing towards upward, and these are the again triangular voids, but these are pointing downward. That means here we get the two types of voids in the first layer, that is the upward pointing triangular voids and the downward triangular voids. In order to maintain the hexagonal close packed arrangement in the base layer A, the sphere of the second layer may be placed either on upward triangular void, means at these places, or on void downward, this downward triangular voids. Layer may be placed either on the void upward triangular or on downward triangular voids. It may be noted that it is not possible to place sphere on both types of voids, that is upward as well as the downward simultaneously. That is, only half of the void of first layer are occupied and half are unoccupied, either upper triangular or the downward triangular. In this arrangement, if spheres are placed on upward triangular void, to make the second layer, which may be labeled as a B, we placed here sphere of the second layer on the upward triangular voids. That means the upward triangular voids are occupied by the sphere of the second layer like this, and this second layer we called it as here B, layer B, like this. These pink color circles are the sphere of the second layer and they cover upward. This is upward triangular voids. That means the downward triangular voids are unoccupied. In the second layer, again, the two types of voids are formed which are not similar. Triangular voids and double triangular voids. These are triangular voids. And these are, which are look like a star, are the double triangular voids. That means there are two types of voids, triangular voids and the double triangular voids. Double triangular types of voids of the second layer are combination of two triangular voids. One triangular void from the first layer and second from the second layer, upper from the second layer, with the vertices of one triangle upward and vertex of other triangle downward. Whenever the sphere of the second layer is placed above the void of a first layer, then a void which is formed is called as tetrahedral void. That means here this void is called as the tetrahedral void. This void is formed because of three sphere from the base layer, and above which this fourth sphere is placed of a second layer, and the void which is formed there is called as the tetrahedral void. These voids are called as tetrahedral voids because the tetrahedron is formed when the center of these four spheres are joined. When the center of this four sphere, that means three from the base layer and one from the second layer, when we join the center of this four sphere, then a tetrahedral void is formed, or the tetrahedral shape void is formed. So it is called as the tetrahedral void. The double triangular void, the triangular void in the second layer are above the triangular void in the first layer, and the triangular shape here or here. The triangular shape of this void do not overlap. That means these are in opposite direction. This green color triangular void of the base layer pointing downward, and this triangular void space of a upper layer which is formed due to this pink color sphere pointing upward. That means they are not overlap. These voids which are formed are surrounded by six spheres. That means this type of voids which are formed here again we call them as a double triangular void, are formed due to the six spheres, three from base layer and three from upper layer. These voids which are formed are surrounded by six spheres and are called as the octahedral voids, which are represented by O, octahedral void, and T, that is the tetrahedral voids. Because they are called as octahedral voids, because a octahedron is formed when the center of these six spheres are joined. Like a tetrahedral void, when we join the center of a six spheres, then octahedron is formed. Therefore they are called as the octahedral voids. This is our AB type of a three-dimensional close packing. But here we form the two layers only, that is the base layer and the second layer. Later on we discuss about the formation of a third layer. Then here the same structure is seen when we consider the sphere here. This is our layer A, AB, two-dimensional AB. For convenience, we consider it as a layer A, and here again we see the two types of a triangular void, that is the upward triangular voids and the downward triangular voids. Then we place the ball on the, or we cover the upward triangular voids by the, this is upward triangular void and downward triangular void. We cover the upward triangular void by the sphere of a second layer. Then this structure is seen like this. It means that the balls which are placed on the upward triangular void forms the tetrahedral void, and here It is a double triangular void which is formed due to combination of 6 sphere, 3 from base layer and 3 from upper layer, and this void is called as the octahedral void. This is called as the octahedral void. Then here we discuss in detail about the tetrahedral void and the octahedral void. Then what is tetrahedral void and the octahedral void? Tetrahedral void and the octahedral voids are commonly called as the interstitial voids or the interstitial sides. Then interstitial voids is the certain hollow or voids are left vacant. These holes or voids are called as interstitial voids during the close packing of a sphere. During packing of a sphere, that after arranging two layers A and B, we find two types of voids. The void created by the 4 sphere is called as the tetrahedral void, and the void created by the 6 sphere is called as the octahedral void. Then first we discuss about the tetrahedral void. The vacant space among a 4 sphere having a tetrahedral arrangement is called as the tetrahedral void or the tetrahedral side. When a sphere in the second layer is placed above the 3 sphere touching one another in the first layer, then tetrahedral void is appear. The center of the sphere lie at the apices of the tetrahedron. It may be noted that the shape of the void is not tetrahedral, but the arrangement around this void is tetrahedral, like this. Here, this is our base layer, and above we place the sphere of the second layer. That means the void which is formed here is the tetrahedral void. And when we join the center of this 4 sphere, then the tetrahedron is formed. That means these 4 spheres are present at the vertices of the tetrahedron. 1, 2, 3, and back is the 4. Here, this is the tetrahedral void. Tetrahedral void. In this way, the 4th sphere is placed, and so the tetrahedral void is formed due to combination of a 4 sphere, 3 from base layer and 1 from upper layer. Then, when we join the center of these 4 spheres which are present at the vertex of the tetrahedron, then tetrahedral structure is formed. Therefore, this is called as the tetrahedral void. Then we discuss about the octahedral void. The vacant space formed by two equatorial triangles with apices in opposite direction is called as octahedral void. Octahedral void. This type of void or site is formed at the center of a 6 sphere. These are the 3 sphere of a base layer. These are the 3 sphere of the base layer, and these are the 3 sphere of a second or the upper layer. It is clear that each octahedral void is produced by two sets of equatorial angles which points in opposite direction. As we discussed before, triangular void of a base layer is exactly opposite to the triangular void of a second layer. This void is therefore surrounded by the 6 sphere lying at the vertices of regular octahedron, like this. 3 of a base layer and this 3 of a second layer, and here double triangular void is formed which we called as a octahedral void. And in this octahedral void, the 6 spheres are present at the 6 corners of the regular octahedron like this. This is octahedral void. After clear the concept of a tetrahedral void and the octahedral void, here we discuss about the formation of a third layer. Third layer can be built up by either placing a sphere above the tetrahedral voids or the octahedral voids. Now, first, hexagonal close packing of a covering of a tetrahedral voids. Here we cover the tetrahedral voids. If the crest of the sphere of a third layer are placed on the triangular shaped tetrahedral voids of the second layer, then three-dimensional closest packing structure is obtained in which the sphere of the third layer lie directly. That means if we arrange the third layer exactly aligned with the sphere of this first layer, green sphere, then automatically we cover the tetrahedral voids. So as layer A or the base layer is similar to that of the third layer in arrangement. Following same placing of layer, fourth layer will be similar to that of the second layer in arrangement, and this structure is seen like this. This is our third layer. We arrange the third layer, sphere of a third layer. Then here we see the sphere of the third layer are exactly placed or exactly aligned with the sphere of a base layer or the first layer, and here we cover this tetrahedral void which are formed due to combination of one sphere of a base layer and a three sphere of a second layer. If the first layer is labeled as a A, second as a B, and as the base layer and the third layer are identical in arrangement, so it is also labeled as A. So this type of arrangement or this type of packing is called as the ABAB type of packing in crystal lattice. This is also called as hexagonal close packing or the HCP. In this, the packing efficiency is 74% and the coordination number of each sphere is 12. For example, beryllium, magnesium, zinc, cadmium crystallizes in SCP crystalline structure. Now here we see how the ABAB type of arrangement takes place. This 7 color violet color balls or the sphere forms layer A or the base layer, above which we placed again 3 yellow ball which forms the second layer. The third layer is formed again a sphere which are aligned with the base layer or the layer A above the yellow sphere. This blue color sphere represents a particular atom, and above which again we placed 3 yellow sphere which are identical to second layer. This structure is seen like this, ABAB. That means layer first is similar to layer third in arrangement. Second, this is the yellow color sphere layer is a second which is identical to that of the fourth one. So this is called as ABAB type of a structure. In this type of arrangement, the coordination number of each sphere is 12. And how? This blue color ball is considered as a particular sphere. We called it as a particular sphere, above which here 3 spheres are there, which are yellow in color. Around this blue color sphere, 6 violet color spheres are there, and below it again 3 yellow color spheres are arranged. In this way, this particular blue color atom is surrounded by 12 equidistant sphere or the particles. So the coordination number of each sphere in ABAB type of arrangement becomes 12. Then here we discuss the formation of third layer, but here we cover the octahedral void. When we cover the octahedral void, then the sphere of the first layer or the sphere of the second layer are not aligned with the sphere of the third layer. That means the third layer which is arranged here is not identical in arrangement with the first layer as well as the second layer. That means its arrangement becomes a totally different than layer A, that is the A base layer, and the second layer. So this layer is represented as a layer C. Then here we arrange the sphere of the third layer like this, and in this arrangement we cover the octahedral voids only, not the tetrahedral void. Octahedral voids, we cover these voids, octahedral voids. So A layer and the C layer is not are not identical, as well as sphere of the B layer are not identical with the third layer. That means this third layer of the sphere is totally different than the layer A as well as the layer B in arrangement. So this layer is called as the layer C, and this type of arrangement is called as the ABC type of arrangement. In this type of arrangement, the coordination number of each sphere is 12. Here we calculate the coordination number of each sphere in ABC type of arrangement of a crystal packing. This is a 7 violet color balls forms the base layer, above which we placed 3 yellow ball, called it as a layer B, and exactly opposite to this yellow ball we placed another 3 blue color ball which are not aligned with the second layer as well as the first layer, and this is called as the layer C, above which we again arrange the fourth layer, which is exactly identical to layer A or the layer base layer. So again fourth layer and the first layer becomes identical in arrangement, above which we placed again 3 balls, and this structure is seen like this: layer A, layer B, layer C, and this is layer A. That means first layer, base layer, and the fourth layer becomes identical. If we place the ball above this layer A, second layer A, then this second yellow color sphere layer is identical to this next, and this is to next. Here we determine the coordination number. This blue color ball is considered as a particular sphere, above which 3 yellow ball and below which 3 blue spheres are arranged. That means 3 plus 3 6, and around this blue color ball 6 violet color balls are arranged. Total becomes 12. So the coordination number in ABC type of crystal packing becomes 12. In this type of arrangement, packing efficiency is 74%, and as we discussed, the coordination number of each sphere is 12. Example of the ABC type of close packing of a crystal lattice are some metals like iron, nickel, copper and silver. These metals have cubic close packing crystalline structure, which is called as a CCP crystalline structure. Thank you for watching the video.